Hello everyone, this is Tejas Raj from Sri Venkateswara College of Engineering from the course of Data Science, and I'm here to tell about Introduction to Operating System Processes. So let's move on. An operating system OS is a software that manages both software and hardware resources. A process is a program in execution. The OS manages the execution of processes and ensures they share the system's resources fairly and efficiently. So let's move on. The next we are moving to process life cycle. So there are 5 steps. The first one is creation, then running, waiting, ready, and fifth is terminating. So the first step is creation. A process is created when a program is loaded into memory and the OS allocates a resource to it. The second thing is running. The process is currently being executed by the CPU. Waiting. The process is waiting for an event to occur, such as an input-output operation or a resource to become available. Ready. The process is waiting to be executed by the CPU and is ready to run. Termination. The process has completed its execution or has been terminated by the OS is called as termination. So let's move on. Now we need to learn what is process states. So the process is in the new state when it is created but has not yet been admitted to the ready queue. The second thing is the process is in the ready state when it is ready to run but it is waiting for the CPU to become available. The third case is the process is in running state when it is currently being executed by the CPU. The fourth stage is waiting. The process in the waiting state when it is waiting for an event to occur, such as an input-output operation or a resource to become available. The fourth thing is terminated. A process is in terminated state when it has to complete it or execution or has been terminated by the OS. So now we'll learn about process scheduling. So for which it gives the priority first and how it be processed. So for the first thing is first come first served. The short form is FCFS. So the processes are executed in the order they arrive in the ready queue as we go in the line. So the first one who goes or entered to the line will be completed first. The job will be completed who goes first. In the same way, first come first served. The second thing is shortest job first. The process which is very easy to solve or easy to complete soon, that will be completed as soon as possible and that will be served the first priority and that will be given as a first priority. So this is called as shortest job, SJF. The process will be the shortest estimated execution time is executed first. Then priority scheduling. Processes are assigned a priority level as the process with the highest priority is executed first. So now we'll learn about process synchronization. The first thing is critical section, a section of a code that accesses shared resources and must be executed automatically. The second thing is mutual exclusion. That means ensure that only one process can access the critical section at a time. Third one, semaphores. So synchronization objects used to control access to shared resources. So now we'll learn about inter-processes communication. The first thing is pipes, a unidirectional communication channel that allows data to be passed between processes. The second thing is message queues, a queue of messages that can be used to communicate between the processes. The third thing is shared memory, a region of memory that can be accessed by multiple processes. Sockets, a communication endpoint that allows processes to communicate over a network. So let's move. Now we'll learn about process management system calls. The first thing is fork, creates a new process that is a copy of the calling process. The second thing is execution, replaces the current processor image with a new program. Third thing is wait, suspends the calling processes until one of its child processes terminates. Exit, terminates the calling processes. So these are the system calls in an operating system. Now we are moving to process resources management. The first thing is CPU management. The OS allocates CPU time to processes based on their priority and scheduling algorithm. Then memory management. The OS manages the allocation and deallocation of memory to processes. File management. The OS manages the access to the files and directories. Device management. The OS manages the access to peripheral devices such as printers, scanners, and hard drives. So let's move on. Now we'll learn about deadlock handling. The first thing is deadlock detection. The OS detects whether deadlock has occurred. The second thing is deadlock prevention. The OS prevents deadlocks from occurring by enforcing certain rules. The third thing is deadlock recovery. The OS recovers from the deadlock by breaking the deadlock condition. Then what is process management? Process management is a fundamental aspect of operating systems. By understanding the concepts presented, you gain a solid foundation for comprehending how operating systems manages the execution of programs and optimize resource utilization. Thank you for watching this video.